In this video, we're going to describe and use three main properties of logarithms. So before we begin summarizing these properties, I want you to first note that for each of these properties, the values for b, which is the base, m, and n, which are two numbers inside of the log, they represent positive real numbers where b cannot equal 1. So b, our base here that we see, is not going to be 1. So that's the first thing that you need to know. Now, what's really great about these properties is that they work for all logarithms. So we're able to now rewrite logarithms in a different way beyond just rewriting logs as exponents and exponents as logs. So the first property here is called the product property, and that's because if we see multiplication inside of a logarithm, so we have m times n, what we can do is we can actually break this logarithm up into an addition problem of two logarithms. So what you're going to notice here is multiplication between m and n means that we can split it up into two logs of the same base. And then from there we'll have a log for each one. So we have log base b of m plus log base b of n. Now to give you a more real example of this, let's put some actual values in there. So say we had log base 6 of, let's say, 5 times 7. Okay? So because I see 5 times 7, in this case we can say m is equal to 5 and n is equal to 7. And I can actually write this as two separate logarithms being added together. So notice that it's still log base 6, but the first one would be log base 6 of 5 plus log base 6 of 7. So that's the first property we'll be using to rewrite our logarithms. The second property here is called the quotient property. And again, notice that we have let m, b, and n be positive real numbers where b does not equal 1. So b cannot equal 1. So here we notice we still have logs of the same base. So here we have log base b and we have m divided by n. So what we can do with that is we can actually take m divided by n and break it up into a subtraction problem. So if we have multiplication, it breaks up into an addition problem of two logs. And if we have division, it breaks up into a subtraction problem of two logs. So say, for example, we had log base 6 again of 5 divided by 7. Here we could break this up and have m represent 5, n represent 7, and this can be broken up into log base 6 of 5 minus log base 6 of 7. And here the order does matter. The denominator comes after the subtraction sign. The numerator comes before the subtraction sign. So the final property here again has b, m, and n being positive real numbers with a b value that is not equal to 1. So here you'll notice that we have a base and a power. So we have m to the power of n inside of the log. So this is called the power property of logarithms. And what we can do with the power property is we can actually rewrite our logarithm. If we have an exponent here, we can bring our exponent in front of the log and it will act as a coefficient out in front. So we can rewrite it with the exponent out in front as a coefficient. So here, for example, say we had log base 6 of 5 to the power of 7. So in this case, again, m is 5, n is 7. What we can do is we can take the 7 and the exponent and bring it out in front. So we would have 7 times log base 6 of 5. So it's another property we can use to rewrite our logarithms. So let's try to test these out. So here it says use the properties of logarithms and the values below to evaluate each logarithmic expression. So here we're given that the value of log base 2 of 3 is about 1.585 and the value of log base 2 of 7 is about 2.807. So we're going to use those approximation values to help us solve these because they are values that we know. So if I look at part A, what I noticed is that this is a division problem. So this is going to be able to use that quotient property that we talked about. And remember that quotient property that we talked about would essentially take two logs of the same base. So we have log base 2 and log base 2. And then we would have the numerator in the first one, the denominator in the second one, and a subtraction sign in between. So what we're able to do as a result of this is we're able to take this single logarithm with division and break it up into two separate logarithms. Now because this problem gave us values of log base 2 of 3 and log base 2 of 7, we're actually able to substitute those into the problem and evaluate the logarithm that we see on the screen. So log base 2 of 3 is 1.585. And then I have log base 2 of 7 is 2.807. So if I take 1.585 and I subtract 2.807, I end up with an answer of negative 1.222. So by using a combination of some given values here, as well as the properties of logarithms, I was able to actually evaluate this logarithm and find its value. Now if I move on to the second example here, this one, it's a little bit more difficult to see what we're doing. We see 21. But because I know I'm going to use the properties of logarithms here, and because I know log base 2 of 3 and log base 2 of 7, I'm going to think about whether or not I can rewrite 21 in terms of 3 and 7. And what I know is that 3 times 7 gives us 21. So I'm going to rewrite this logarithm as log base 2 of 3 times 7. And in doing so, I've all of a sudden created a situation where I can use the product property of logarithms. And remember, the product property of logarithms allows us to break up this logarithm into two logarithms with the same base, so log base 2. You put the first term being multiplied in the first logarithm, second term being multiplied in the second logarithm, and then an addition sign in between because they can be added together. So we were able to use the product property of logarithms to split it up into an addition of two separate logarithms. Now from here, all we need to do is substitute in the values that we were given and simplify. So we have 1.585 plus 2.807. And if I add those together, so 1.585 plus 2.807, I end up with an answer of 4.392. So again, able to use properties of logarithms tied together with some given values in the problem. Now, the final problem here, we need to think about what we can do with 49. Now, what I know about 49 is that 3 and 7 together do not make a combination of 49. But what I do know is that I can use 7 to create 49. So 49 can really be represented as 7 squared. So what I'm going to do here is I'm going to rewrite this logarithm as log base 2 of 7 squared. And then I can actually utilize the power property of logarithms. Remember, we can bring the exponent out in front as a coefficient. So I can rewrite this as 2 times log base 2 of 7. And now, as a result, I can evaluate this because I just have 2 times whatever log base 2 of 7 is, which in this case I was given is 2.807. So I have 2 times 2.807, and if I multiply those together, I end up with a value of 5.614. So just being able to utilize those logarithm properties and approximate values, we were able to simplify all 3 of these logarithmic expressions.